All right, guys, this is going to be some of the practice problems for chapter 3. Again, your book calls them solved problems. I'm going to use those terms interchangeably as I feel like. So we're looking at problems 1, 2, 3, and 7 from the back of chapter 3. I'm going to be adding a little bit to some of them because there's some additional stuff you'll need to know in order to do some of the work that you're assigned for this chapter. So I'm going to add a little bit additional context, but for the most part, you should be able to follow along with the book. This first problem asks you to prepare a forecast for period 6 using 4 different types of forecasting methods: the naive method, a 3-period moving average, a weighted average using the weights of 0.5, 0.3, and 0.2, exponential smoothing with a smoothing constant of 0.4, and then I've added linear trend because one of the assignments you'll have to do, problems you'll have to do for the chapter 3 involves a similar thing to this, but includes linear trend as well. So the first thing we want to do if we're going to be using linear trend is determine if linear trend is acceptable or appropriate, rather, not acceptable. And how we do that is we want to highlight periods 1 through 5, the periods in which we do have actual data. We can't highlight period 6 because we don't have any actual data. We're going to highlight those things, and then we're going to go to Insert tab and then insert a scatter plot. And what we're looking for is a trend. We're looking for these dots to potentially follow some kind of upward or downward trend. And what we see instead is womp, 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 and not so much of a trend. So probably linear trend would not be very accurate of a method and not appropriate for this data. So we shouldn't do it, but we're going to just for the practice anyway. Now, one thing, if you're going to be ever completing a chart of any kind, you always want to title your chart. So we might say this is number of complaints per period. Okay, it's really important in business that you give context to your charts, and also your X and Y values should always be labeled. So I'm going to add axis titles, and then I'm going to title those. It's going to be number of complaints and period. Okay, and then number of complaints per period. And then we've done our job. We've labeled it so people that are looking at our visualization of this data can know what's going on. All right, in period 1, we had 60 complaints, and it doesn't appear to be following any kind of trend. So now let's look at our various forecasting methods. Naive method, no matter what, is always going to be the previous period's value. So I would say equals 60 this period, all right? It doesn't matter if I see this 60, 61, 62, 63, 64. It's not 65. I might try to trick you on that later in the quiz, perhaps, but it's not 65. You know, just because you see numbers going up, it's not anything to do with any previous period but the most recent one. Okay. So you just look at the previous period, and that's how you would do that. Okay. No math to be done. There it is. Now, a 3-month moving average is going to be the average equals average of the last 3 periods. How would I do this by hand if I was calculating it outside of Excel? Well, I would add up the sum of the 3 previous periods, so 64 plus 58 plus 55. And then because there's 3 periods, I divide by 3, 59. You can see those answers match. Easy enough there. Now, a weighted average is a little bit different. In a weighted average, I'm going to apply a weight to this number, and this number to give more weight, more credence, more care to the most recent period, a little bit less here and a little bit less here. Because the most recent period is probably going to be the most determinant on my next period demand, right? If there is a trend, then it'll be trending in that same direction. So I want to give more value to this most recent period. So how I'm going to do this is I'm going to write in the weights given to me, and I'm not going to write them 0.5, 0.3, 0.2, because what I want to do is I want to match up this with this, and 0.5 is the most recent period. So I'm actually going to put my 0.5 here, 0.3 here, 0.2 here. And then in this in this value here, I can a couple different ways I can do this. I can either do equal 0.5 times this number plus 0.3 times this number plus 0.2 times this number. It's a little time consuming. And if I was going to do a weighted average of maybe the last 5 periods, it takes me a long time to do that. You get the right answer, but there's a better formula you can use, one you're going to want to use in this class quite a bit. It's called sum product. So I type equals sum product. Sum is what you get when you add numbers together. Product is what you get when you multiply numbers together. So I'm going to multiply 0.5 by 0.6 or 0.5 by 64, and then add that to 0.3 times 58, right? So I'm summing the products, equals sum product. And when you type this, it asks you to fill in 2 arrays or more. So the first array is going to be my weights, comma. My second array is going to be the number of complaints in periods 3, 4, 5. And then I just hit enter, get the same number. So if I wanted to have 4 weights, I would just highlight these 4 and these 4, right? But that's it, equals sum product of select 2 different arrays, but they have to match up. If I had written 0.5 here, 0.3, 0.2, and put them in the wrong order, it's going to try to match up this one to this one, 0.5 to 55. And that's not correct because 0.5 is the most recent period. So how would I do this one by hand? Well, I would just have to do one at a time, write them down in between. So I would do 64 times 0.5, 32, write that down, on paper, right? 0.3 times 58, which is the period 4, get 17.4. And then 0.2 times 55, which is 11. Now I add them together. So 11 plus 17.4 plus 32, I get 60.4. That's how I would do a weighted average. And if I change the weights, what's nice about doing the sum product is, let's say I wanted to maybe test and see, would I be more accurate if I did maybe 0.6 or 0.1? And then when I run this through the checks for accuracy later, I could adjust these on the fly, and it would automatically adjust the ending value for me. That's one of the benefits of doing things in Excel. All right, the exponential smoothing method. So this one takes a little bit more work to set it up, in that I can't just project period 6 because it's going to be every known value leading up to period 6. So I start by looking at this through the naive method, actually. And I do the naive method in the oldest period in which I can do a naive method. The naive method says I look at the previous period value. So the only period where I have a previous period would be period 2. I can't do period 1 naive method because there is no period 0, right? So I start here and I say equals 60 because that's the previous period. So I have to start at a value, okay? And then once I have 0.6, or once I have 60, now I start the method. The method is I take the forecasted amount, which is 60, and then I add to that a percentage of the error. And you get a percentage of the error by taking the smoothing constant, which I type in here, also known as the alpha, because that's the Greek symbol we use to represent the smoothing constant. We can call it the alpha. And we want to use an alpha of 0.4. So the alpha is going to be multiplied by the difference, the actual minus forecast. And then I'm going to adjust in that direction a little bit. So instead of saying 65 the next period, I'm going to adjust by a percentage of that difference. So here's the formula at play. I'm going to take the forecasted amount plus the alpha, which is right here, times, and I got to open my parentheses because I need to do the math first before I multiply it. Order of operations matters. Actual minus forecast. Actual minus forecast. Close my parentheses, enter, and I get 62. So I was off by 5, right? 40%, 0.4 times 5 is 2, so I'm adjusting it by 2. How would I do this by hand? I would look at, first I would have to get the actual minus forecast. So the actual is 65 minus 60 is 5. Multiply it by the alpha, 0.4 times 0.4 I get 2, and then 2 plus the forecast, plus 60, I get 62. Now keep in mind, this is not the absolute value of the difference. If I'm off by a negative amount, I do go back the other way on my projections. So if I do actual minus forecast for the next period, I get 55 minus 62. Well, I'm going to be at a negative number. So 55 minus 62 is negative 7. Multiplied by 0.4 is negative 2.8. But I'm still adding that to the forecast. So plus 62. And I end up with 59.2. So I should get 59.2 if I follow this same formula. Now, here's a trick with Excel. If I want to copy a formula down, it'll work if I do all of my references correctly. Problem is, when I shift a formula down, it's going to try to shift all of these values down by 1. And while the number of complaints, I want to shift from period 2 to 3. And while the value here, I want to shift down as well. What I don't want is for this alpha to move. So what I have to do when I'm writing my formula initially is look at where the alpha is, E15. And I can add a dollar sign before the E, and that locks in the column. And I can add a dollar sign before the 15, and that locks in the row. And when I do that and copy it down, it locks that value into place, and you can see I get 59.2, which is the same value I got on my calculator. So let's undo that for a second. If I had not locked that in and copied it down, it's trying to multiply by the words in this cell. If I copy down again, same thing, it's multiplying by nothing. So it doesn't quite work. So let me write this one more time so you can see it if I'm locking in that cell as I write the formula. The nice little shortcut we could use. So forecast was 60 plus alpha. Well, I'll lock in my alpha right now. Now, if you're using a desktop computer, you can usually just press the F4 button. And you can see F4 is a shortcut to add the dollar sign between both the letter and the number, the column and the row. If you're on a keyboard, if you're on a Mac operating system, then on the home row of keys, the very bottom row of your keys, you're going to see a button that says FN, which stands for function. Because usually on a laptop, those F keys, those function keys, will do something else, such as adjust the brightness or adjust the volume or mute, right? So you hold the FN button when you press F4, and that changes it from whatever the function normally is to just whatever F4 does on your computer. Either way, you're either going to press F4 to lock it in or function F4. And if it's still not working, you can always just manually type in the dollar sign before the letter and the number. That works too. All right, back to the formula. We've locked in the cell that's containing the alpha. We're going to multiply it by, open my parentheses, actual minus forecast. Hit enter, I get 62. And now I can just copy this all the way down. I change this value back to yellow though, so it matches. And that's it. That's my exponential smoothing method. You can copy it all the way down. So you can do one line at a time by hand to get to the forecast you're trying to make. Or if you do the formula correct the first time in Excel, you can just copy that formula down. Again, you drag the very bottom right of the cell, click it and drag, and it copies that formula down for you. The final method is to do the linear trend method. Again, linear trend was not appropriate because there is no trend here, but we're going to do it anyway. And the first step of doing a linear trend is figuring out two values. Those are called the intercept and the slope. We usually represent those with an A and a B. And depending on the book, they might change A and B around. They might call it different letters, but the intercept plus the slope times time. That's how we run our formula, but we got to find the intercept first. Fortunately, I'm not going to have you do the math to figure out the intercept. Very long, complicated formula. Instead, I'm going to let you just type it equals intercept. If I can type, what is happening? Equals intercept, all the known Y values. The Y values are what we are trying to predict. The predicted value of Y is the predicted demand. And the X values are known as explanatory variables. X explanatory, easy way to remember which one's X and which one's Y. The X values explain why something is the way it is. You're welcome for that cheesy mnemonic device. And so the known Y values are the number of complaints. That's what we're trying to predict, number of complaints. comma, the known x values are the explanatory variables. So what period are we in? That was the only explanatory variable we possibly have. And then I hit enter, and then I've got my intercept. This is my baseline in a trend forecast. The slope is how much does it trend upwards or downwards. This might be a negative number, it might be a positive number. How do I find it? Well, I just type equals slope. The y variables are what we're trying to predict, comma, the x variables, what is explaining them. Now I have my intercept and my slope, and based on this complex calculation, I can say if we started at 60.1, we're going to go up every period by a number of 0.1. Okay, so 60.1 would be period 1's forecast, 60.2, 60.3, 60.4, 60.5, 60.6. We're going up by 0.1 every period. So intercept is the alpha plus the slope times whatever time period it is. Right, so period 6 would be 6 times 0.1. 6 times 0.1. That's my b times t. And then I'm going to add to it the intercept plus 60.1. Actually, it's 60.7. That's what I'm going to end up projecting, which is, different than the rest of them. It might end up being accurate, but over time, it's probably not going to be because there is no trend here. Let's see how I do that on this. I take the intercept value, lock it in with my F4 button or function F4, depending on what kind of computer you're using, plus slope, lock it in, times what period am I in? 60.2, and I just copy that all the way down to the end. Again, I don't have to do all those periods for this one. I just need times 6, but I'm just showing you how you could trend out all the way up. So for this assignment, we would have only needed it to be filled in right here because we don't care to project period 1. If we were judging the accuracy, we would need to fill in as many cells as we could, and then we would monitor for accuracy. So that's the an easy way of doing all of these 5 different types of forecasting. So now let's look at seasonal relatives. So in this problem, and you have a similar problem in your problem set, but in this problem, you are given the intercept. You're given the formula as 402 intercept plus 3 times t. And t is what period you're in. And so from a forecast for any period, I need to know what period number am I currently in. In this problem, we're actually not told what period number it is because we have last year's value, this year's value, next year's value. And in this particular problem, t equals 0 is equal to January of last year. And in this problem, we're trying to project next year's January, February, March, and April, and then run them through a seasonal adjustment. For this problem, I need to set last year's January to 0. And then I just start filling in all the numbers. And I can do this by hand, or once I have at least 2 values there, I can copy down and Excel tries to fill in the blanks. Now the next row I need to fill in 12, 13, and I can do it again. Oops. 23, 4, 25, 26, 27. I can probably just type in 4 faster. So now I know what the period is for next year's January. It's going to be 24, 25, 26, 27. And you can do this easily enough by hand by writing in those numbers, right? Don't be confused by December being the 12th month. That can trip you up. It depends on what the period is that you start in, and then forecast. So if I'm going to forecast this out, I need to take the intercept plus slope times period number. So next January is 24. If I was doing this by hand, I would do 402 plus 3 times t. When you're doing it on a calculator, it's a lot easier to do the multiplication part first. 402 plus 3t is the same as 3t plus 402. So let's do the second part first. 3 times the period numbers, 3 times 24 plus 402. So 474 would be my forecast, and I can do that for all three of the remaining periods. Or I can do equals intercept, lock it in, plus plus slope, lock it in, times that period. You get 474, same number I got here, but because I did it one time correctly, I can copy it down and I get the forecast for all 4 periods. Now the last step is to adjust January, February, March, and April by the seasonal relatives that I've established by looking at all the historical data I had available to me. So to do that, I just take equals the forecasted amount and multiply it by the relative, and I'm going to adjust it by a little bit. A lot of it there. And then I'm done. And that's that problem. That's how to apply a seasonal relative. The next step is just forecasting demand. This is the problem number 3. You got to find the intercept and slope though. So again, finding the intercept is the simplest, saying intercept equals intercept of the y values. What am I forecasting? I'm forecasting demand, so that's the y value. X variables explain the forecast. Slope, same way. Here's my y values, comma, x values. Now for this problem, we would want to, before we started, figure out is a trend, linear trend formula appropriate. So let's do what we did before on problem 1. Let's highlight all our numbers here. Go to insert and insert a scatter plot. Yeah, it certainly appears that there is a slight upward trend here. It goes up and down, but this is a lot more trendy than that problem 1 was. And I can do that by inserting a trend line and saying that it cuts it pretty close down the middle. Anytime I'm asked to insert a chart, you definitely want to give it labels. So this would be demand, this would be period, and this would be demand by period. Sure, easy enough. All right, so now we want to forecast our demand. Because of the trend equation, I could do slope 1.75 times period, which is 10, and then add to it 45.47. 62.97 is what I should be projecting here. Let's do it with Excel instead. Intercept, lock it in, plus slope, lock it in, times period. 62.97, same answer. Copy it down once, I get the next answer. Done, that's problem 3. Now let's jump all the way to problem 7. In problem 7, you are asked to look at 2 different techniques. And in those techniques, find the how far off you were as an error. So I'm going to look at these values here, and I'm going to find the error. The error is actual minus forecast for technique number 1. I was off by 4. I'm going to copy that down all the way. And if I wanted to, I could copy this and paste it here right now, because it's going to match up all of these. They're going to match up exactly. It's shifting everything down exactly by the amount I wanted to. Nice. What's the absolute value of my error? So, if I'm doing this by hand, I can just look and say, well, the absolute value of 4 is 4. I could write that in. Negative 14 is just 14. All I'm doing is removing a negative. I'm looking at the true difference of those. But if I want to do this as a quick formula to do it for me, ABS is the name of the formula for absolute value. And then I just click on absolute value of that. Copy it down. And it turned all those negatives into positives. I could copy and paste this here. And now I've got both of them compared. Now I want to square the errors. 2 options here for squaring an error. It's probably actually more. But to square a value, it's the number times itself, right? So I could do equals this number times this number. But let's say I wanted to get it to the 5th, right? This value to the 5th degree, I'd have to do times this 3, 4, 5, right? Take a long time. So in Excel, you can actually, if you hold Shift and then push the number 6, you have this little up arrow symbol. And this means to the nth degree. That's what it does for you. And so I want to square it. I would just say to the 2nd degree. If I wanted to do it to the 5th degree, I could do that. To the 10th degree, I could do that. So a little updo 2, and it's going to square it. 4 times 4 is 16. Or I could do, again, equals 4 times 4. And that's easy enough if you want a calculator too. Maybe not for 4 times 4, but 14 times 14, you might want to do on a calculator. Either way, it gets me there, and I can copy that. And then once again, copy it down below. 3 times 3 is 9. 12 times 12, that's gross. A little math joke for you. That's what it's called. A dozen, it's called a gross, if you're not aware of that. 144, and so on. Now let's look at the error as a percentage. How far off was I? I take the absolute value of the error and I divide it by the actual. I was off by 0.81%. Copy that all the way down. Copy that down here. Now it's up to me to determine, well, what do these numbers mean? Which one's better from a point of view of MAD, MSE, and MAPE? Well, MAD is the average of these numbers, okay? The mean absolute deviation, the mean difference of the absolute values. So mean is average, right? So I just take the average, and then I'm done. 4.67, and guess what? I can copy this and paste it here, and I'm done now down there too, because it's going to take the average and it's going to shift everything down exactly the same amount. So as long as my setup's the same, I'm good to go. If I want to do this one by hand, I could just do 4 plus 14 plus 5 plus 3 plus 1 plus 1, and then divide by 6 because there's 6 periods. I get 4.666 repeating, 4.67. I'm going to skip MSE. We'll come right back to it. Let's look at mean absolute percentage error. This one is also average of these periods. I'm off by an average of 0.97. Copy it here. So this one was, now when we're looking at this, let me, because I didn't say it already, lower is better. The lower all of these errors are, whether it's a percentage or an absolute value, the lower the number, the better. So in both these cases, based on MAD or MAPE, technique 1 has been more accurate. And so MSE, the difference here is that you can't use an average. If you use an average for MSE, you're going to be close, but not accurate, because we're going to smooth this out a little bit by dividing it not by 6, but by 6 minus 1, the count minus 1. So what I want to do, if I'm doing this by formula-wise, the sum of these numbers, and I'm going to divide it by the count of these numbers. And when I do this, I need to open my parentheses earlier because I want it to count minus 1 first and then divide it by that number. So open my parentheses, count of these numbers, close my parentheses once, minus 1, close my parentheses a second time. This one's a little more complicated, but you can see here that I've got outside parentheses here. So count minus 1, whatever this count is, count this, I get 6. 6 minus 1 is 5. So I want to divide my sum by 5. This should work. And we'll do it by hand to see if I got it correctly. 49.6. Let's see if that's right or not. Oh, let me get rid of these little drawings. So we can do the math by hand to see if I got it right. So it's going to be 16 plus 196 plus 25 plus 9 plus 1 plus 1. I get 248. And again, I'm not dividing by 6. I know that the 6 minus 1 is 5, so I'm going to divide it by 5. I get 49.6. So there we go. Copy this down to here, 52.8. So in all cases, technique 1 was more accurate. We should be using whatever technique we use. It doesn't tell us, maybe this was weighted moving average and this was simple moving average or something like that, right? We don't know what the techniques were. One of them maybe have been trend. All that we know is that we're comparing 2 different forecasting techniques. So in all cases, this was a more accurate one. That's the one we want to go with. And that is your practice problems / solve problems for chapter 3. Thanks, everyone. I'll see you in chapter 4 and 4S.